Okay, 8th graders, I'm going to go through a topic called angle relationships, which can be confusing for many students, but it's actually pretty simple. So I want you to have a look at these 4 diagrams right here, and we're looking for a pattern. What we're looking at are parallel lines A and B intersected by a third line called the transversal C. And we want to look at the angle measures in each of these diagrams and see if we can find a pattern. So let's look at 40 and 140 and take note that 40 plus 140 adds to 180. Also look at the position of the angles. Both angles are on the same side of this transversal, this intersecting line C, and they're both on the interior or on the inside of the parallel lines A and B. So the angles are on the same side of the transversal and they're on the inside of the parallel lines. And note how that's true as well here. Both angles are on the inside of the parallel lines and on the same side of the transversal. Same side of the transversal and on the interior or the inside of the parallel lines. Down here, it's a little less obvious because we haven't used angle measure, but those little boxes mean right angles or 90 degrees, and notice how both of those are on the inside of the parallel lines and on the same side of the transversal. And the same is true down here. These angle measures, which are hidden inside algebraic expressions, 5x plus 30 and 2x plus 5, are on the same side of the transversal, and they are on the inside or the interior of the parallel lines. So that's one pattern we can notice. And then the other one, perhaps a bit more obvious, is 40 plus 140 is 180. 70 plus 110 is 180. 90 plus 90 is 180. So if this pattern for same side interior angles is going to hold, 5x plus 30 and 2x plus 5 when added together will also equal 180. Which means we can write and solve an equation to determine the measure of the angles and the value of x. 5x plus 30 plus 2x plus 5 is equal to 180. Now this is a little bit different than what we've been doing. It is not the case that 5x plus 30 is equal to 2x plus 5 because of the pattern. 40 plus 140 was 180. 70 plus 110 was 180. 90 plus 90 is 180. So 5x plus 30 plus 2x plus 5 will also equal 180. So we're setting up the equation a little bit different. But now think back to the warm-ups and everything I've said about variable terms and constant terms. Variable terms can be added together, constant terms can be added together, but variable terms and constant terms must be kept separate. So 5x plus 2x is 7x. 30 plus 5 is 35. And those two terms, this variable term, 7x, and this constant term 35 are going to be permanently kept apart by that plus sign. But when you sum these two, whatever they are, to 180 degrees, you've now got a very simple equation that you can solve based on the strategies we've learned in class. Subtract 35 from both sides, 0 pairs, 7x plus 0 equals 145. That 0 influences the equation not at all. So 7x equals 145, and this particular answer is going to come out to a not very nice number, but here's where the calculator can be very helpful. 145 divided by 7 is 20.714. So we'll just round that off to 20.71. Divide both sides by 7. According to the calculator, x is 20.71, or approximately equal to 20.71. So I encourage you to review this video to understand why this equation is set up as it is. Now I'm going to show one more example of angle relationships, but this time we're going to be relying on triangles. So it's still an angle relationships problem, it's just different relationships. So again, we're looking for patterns, and we want to see the relationship between these two angles and this angle here. These two angles are called interior angles, and this one is called an exterior angle because these two are on the inside of the triangle, and this one is on the outside or the exterior of the triangle. And we can call these two opposite interiors because they're opposite this exterior angle. You don't need to get bogged down in the vocabulary. You just need to see the pattern, the relationship between the angles. Again, we have a little box signaling 90 degrees. 90 degrees plus 50 degrees is 140 degrees. So these two interior angles add up to this exterior angle. Here's another example. These two interior angles, which are opposite this exterior angle, sum to 160. 135 plus 25 is 160. Here again, two opposite interior angles summing to this exterior angle, this angle that they are opposite of. 35 plus 180 is 115 degrees. So, having established that pattern of these two opposite interior angles being equivalent to this exterior angle, we can write an equation that goes with this problem. For x plus 70 is equal to 8x. And now we have a very simple equation that we can solve. Subtract 4x from both sides. Zeros out. 70 equals 4x. Divide both sides by 4. 4 divided by 4 is 1, so that just leaves x. 4 goes into 70, I think 17.5 times. So x is 17.5, and I will check that on my calculator. 70 divided by 4 is indeed 17.5. So these are called angle relationships, and or angle relationship problems. And again, I encourage you to go back and rewatch the video and understand why I set the equations up the way I did. In the case of the triangle, the opposite interior angles sum to the exterior angle to which they are opposite, and that's established in this pattern here by looking at the sequence of diagrams. 90 plus 50 is 140. 25 plus 135 is 160. 80 plus 35 is 115. So 4x plus 70 is equal to 8x, and then we can solve for x. And in the case of the parallel lines cut by transversals, we identify the locations of the angles. They are on the same side of the intersecting line, and they are on the inside of the parallel lines. And by looking at the angles that are all in those positions, we can begin to establish a pattern. 40 plus 140 is 180. That's supplementary when two angles add up to 180 degrees. 110 plus 70 is again 180 degrees, so those two angles are supplementary. 90 plus 90 equals 180 degrees, so again we have supplementary angles. So 5x plus 30 plus 2x plus 5, because the angles are in the same location, same side interior angles, they are also going to sum to 180 degrees. They are also supplementary angles. So we take this angle, 5x plus 30, and add it to this angle, 2x plus 5, and then set that sum, the sum of those two angles, to 180 degrees, and solve for x.